So in this experiment, a student investigated the progress of a reaction between dilute hydrochloric acid and excess of calcium carbonate. We did the first three parts. The first part, how does the shape of a graph shows that the rate of a reaction decreases? Because the slope is decreasing, that's why the rate decreases. Why the rate of a reaction decreases? Because the number of the particle or number of reactant particle decreases. How many minutes, how many seconds did the reaction finish? So once the volume is constant, you can see at this point the volume start to be constant. It's a straight line. Volume does not change. So what is the time at which the volume start to be constant? So that time is equals to 120 seconds. That's why it is equals to 120 seconds. The experiment was repeated using the same mass of small pieces of marble. All the conditions are same. So, but small pieces, we are using a same mass. All the conditions were kept same, but small pieces. So what will happen if I use small pieces of calcium carbonate? And we have to draw a graph on the grid to show the progress of the reaction with the small pieces. So what will be the shape of the graph? It will be much steeper or less steeper compared to. So reaction will be faster or it will be steeper. But the final, because we took the same we took the same amount of the reactant, so final product will also be same. So you should draw a steeper, but the final volume should be same. Then the original experiment was repeated using a higher temperature. All other conditions were kept same. Explain in terms of, and you can see it's a five mark question. So what is the distribution of the marks? It's always important to understand the distribution of the marks or the point, which are important when you want to answer these type of questions. So higher temperature, reaction will be faster because there are more effective collagen or more collagen per unit in a unit time. So it one mark is for mentioning it will take less time for reaction to occur. Second mark, the particle will have more energy. The third mark, the particle will move faster. Fourth mark, the particle have more collagens. And the fifth one, the particle will have enough energy to collide or more successful collision. A student investigate the rate of a reaction between lumps of calcium carbonate with hydrochloric acid. Which measurement should be which measurement should the student make using during the reaction to determine the rate? So what he should measure? He should measure the volume of a gas and the time interval. Because to measure the rate or the speed of a reaction, here we are measuring the volume of a gas, so he should measure the volume of a gas. And the second thing is a time interval. What happened to a rate when the reaction proceed? So what happened to the speed or the rate of a reaction as a reaction proceed? So it will decrease, rate always decrease. It will decrease because few particles So because the number of the reactant particles decrease, so what will happen as a reaction proceeds or reaction will go on or reaction will complete? So it will the rate of a reaction will decrease because number of the reactant particle decreases, which result in few collisions. The student repeated the experiment at higher temperature. All other conditions are kept same. So what happened in terms of collision theory? So higher temperature, the reaction rate or rate of a reaction will be faster. Particle have more energy. Particle will move faster. So more collision result in faster rate. It's a similar answer. Apart from using a higher temperature, suggest two methods of increasing a rate. So if you want to increase the rate other than temperature, so what we can do, we can use a catalyst. So to increase the rate or the speed of a, we can use a catalyst, or we can increase the concentration or decrease the particle size. These are the factors which will affect the speed or the rate of reaction. This was exercise 2. Now exercise 3. Just an overview of all these exercises I will share with you as a weekly homework. One of the question I will solve and other questions are similar that you can solve as a homework. This is exercise 3 of speed or rate of a reaction. A student is investigating the rate or the speed of a reaction between hydrogen peroxide and aqueous potassium iodide. When these chemicals reacted, they form iodine. Sodium thiosulfate react with iodine and can be used to show how fast the reaction proceed, or proceed means how the reaction goes on or how fast the reaction complete. A burette is an apparatus which is used to measure the volume of the solution, was marked to 0.0 centimeter cube, and thiosulfate in a large measuring cylinder 100 cm cube of distilled water was added. This is all what is done, but when you read the question you find it's you can even answer the question without reading this whole paragraph, because what we have to do on this, we have to complete the time at which the blue color appeared. So how we'll read this, this is a stopwatch. So how we read this, you can see here the inside inside dial is for minutes and outside dial is for second. So inside dial is at 0 and outside dial is at 15. Each is representing like 1. So this is 20 and 22. So what is the time? That's 22. What about the time here? 22 seconds. What about time here? This one is 43. When what about this one? You can see 1 minute and how many seconds? 1, 2, 3, and 4 seconds. So 1 minute and 4 seconds. 1 minute is having 60 seconds. So how many seconds will be there? It will be 64. Is it clear how we work out the time in seconds from this stopwatch? This is a paper 6 question. Mainly in paper 6 questions, you have to use the intervals or read the instruments. Then this is 1 minute and how many seconds? 20, 25, 26. So 26 seconds are there in 1 minute. So 60 plus 26. So it will be 86. Same way, this is 1 minute and 45 seconds. So 1 minute is having 60 seconds and 60 plus 45. So this will be 105. And this is 2 minutes and 6 seconds. So 2 minutes means 120 seconds, 120 plus 6. So it will be 126. So you have to complete this table. So what are the values here? The first value for was second only. So it was 22. The second value was 43. The third value is 64. The fourth value was 20, 26 plus, yeah, this was 86. Then it was 105 and then 126. So these are the numbers, the time taken by the blue color to appear. Then using a grid, we have to sketch a graph, draw best fit straight line or plot the results. So you have the time, but you have the time interval, you have to select a scale here according to the graph so that you can fit these numbers, the numbers which, so you have to select a scale which can fit all these numbers 22, 43, 64, 86, 105. So your scale, if it starts from 0, so it should be from 0 to 130 or 140. And I will work out the points, the time interval, and using the time interval, I will plot a straight line graph. It will be a best fit straight line graph. And from your graph, you will deduce the time at which the blue color would appear if the total volume is 4 cm cube. So I'm just giving you a rough idea how it will be done. So when you plot a graph, what will be the shape of the graph? As you can see, the time was increasing. The time for for time at which the blue color appeared, it was increasing as we were increasing a volume of thiosulfate. So the graph will be somewhat like this. Now in the next part, in part C, they mention from your graph, deduce the time at which the blue color would appear if the total volume is 4 cm cube. So if the total volume is 4 cm cube, so what we will do, we will extend this line. We will extend this line, a straight line, until it reaches 4. And we will identify, because on y axis we have a time, so we'll identify what is the time interval, and that will be our answer. Because you will have a graph, as you can see, you have the volume of a solution. The volume of a solution is 0.5 till 3. So you started your graph with a point of 0.5, means you will have 0.5 on your graph and you will have 3 on your graph, but you don't have 4. So if you don't have 4, how you can identify how much time it will take for a cross to, or not about the cross, it's about the blue color, appearance of a blue color. So this will be the shape of the graph. It will be a straight line or a best fit straight line. which started from 0.5 and it will end at 3. This is what you will have. But in the question, you need a time for the blue color to appear when the 4 cm cube of solution was used. So for this purpose, you will extend the straight line using a ruler or a scale. Extend the straight line. When you extend the line, now you can see the volume is 4 cm cube. So if volume is 4 cm cube, how much time it will take for the for the blue color to appear? That time you will read on y-axis, and that will be your answer. Answer for this part C. Sketch on the grid. If experiment was repeated higher temperature. So if you repeat the experiment at higher temperature, because if a reaction is faster, then this blue color will disappear in a short time. So if this was the original graph, I want to make, or blue color will appear in a short time if the reaction is faster. So when I sketch a graph, another graph will be there, a parallel line to this. You can see, like example, if this was experiment 1, in experiment 1, if the first example, it was taking the first value, if I say this was the first value, so it was taking about 26 seconds or 22 seconds to disappear, to appear. So if it was taking 22 seconds to appear, but if I repeat the experiment at a higher temperature, then it will appear in a short time. So maybe it will take example 10 seconds. Same way, the finally, when volume was 3, it was taking 126 seconds for the color to appear. But if I repeat the same experiment at a higher temperature, it will take less than that. So experiment 2, or the experiment which is faster, also show a same trend, but take less time. That's why the line will be below. Is it clear? So this experiment is slow experiment, the first one, and the second experiment is a fast experiment. It's the same idea. Look, if you have, these are the values. So this was 22. This one is 43. This one was 64. This one is 1 minute and 26 seconds, so 86. This was 105 and 126. But if I say I repeat the same experiment but at a high temperature, at a higher temperature. So if I repeat the experiment at a higher temperature, so this will take a less time. The time at which the blue color appear, it will be a short time interval. So example, maybe it will take 10 seconds. This will take 30 seconds. This is just rough values I'm mentioning. This will take example 44 seconds. This will take 56 seconds. This will take example 90, and this will take 100. So when you have the first graph, when you plot your result for the first graph, it was coming out like this. So if I say plot the result for the second graph, which is faster, so same trend will be there, but it will take less time for this blue color to appear. In the first graph, it was taking initially 22 seconds, but in the last graph, the second experiment, it is taking 10 seconds to appear. That's why it is faster at a higher temperature. Is this clear? So this will be the shape of the graph which you will have when you complete this exercise. Any doubt in this? Is this clear? Then what is the purpose of the starch? The purpose of the starch is used for identification of iodine. Because whenever iodine is there, the starch will turn blue black in the presence of, if there is iodine in the solution and we want to test, because like example, if there is a colorless solution, so if there is a colorless solution and I want to test that whether this colorless solution contain iodine molecule, so what is the test to check the presence of iodine? We add a starch solution. So when we add a starch solution, it will turn blue black in the presence of iodine. So the purpose of iodine solution is always to identify whether a solution is having starch. A purpose of a starch solution is to identify whether a solution is having iodine in it. What is the advantage of using a pipette? Pipettes are more accurate, so it is accurate to measure the volume. So if we are measuring a volume of a solution, we can use pipette or burette, which are accurate. Suggest and explain one disadvantage of using a pipette. So when there is also a disadvantage, because the pipettes, it take more time to transfer the solution. Accuracy is one thing, that's an advantage when we are using a pipette, because pipette is accurate, it can measure the volume accurately as possible. But what is the disadvantage? Pipette take more time to transfer the solution. It takes more time to transfer solution, which make the time measurement inaccurate. How the time measurement will be inaccurate? As you are measuring a time as well, in this experiment you are measuring a time as well, but as the pipette is taking more time to transfer the solution, so that measurement of the time is also included, not only for reaction, it is also for transferring a solution from pipette to a flask. So it will take more time to transfer a solution. So as it take more time, so it will increase the inaccuracy in measurement of the time interval. Explain one disadvantage of using a beaker instead of conical flask. So if we use a beaker, because if we want to stir, like what is the difference? This is a beaker, and what is the advantage of using a conical flask? So conical flask, it is convenient or easy to mix the solution in a conical flask, because the small opening is there. So when I mix or shake this solution, it can easily thoroughly mix. But in case of beaker, we cannot mix solution easily without using a stirrer. So we need a stirrer, or we need a stirring rod, so that we can mix the solution. So what is the disadvantage of using a beaker instead of a conical flask? So what it will do, So it is difficult to mix a solution in a beaker compared to that of conical flask. Is this clear? Any doubt in this? These are experimental techniques which are used for certain experiment. Then another experiment, a student investigate the rate of a reaction between excess of hydrochloric acid with a magnesium ribbon. So he's using this as a magnesium ribbon and he used hydrochloric acid. Two experiment was carried out, temperature was same in each experiment. Complete the boxes. So what is this? This is a conical flask. And this can be graduated gas jar, or you can mention measuring cylinder. Inverted measuring cylinder is there. Give one observation expected during this reaction. As we know, when metal react with acid, so it will give hydrogen. This you will learn in acid chapter. Metal plus acid, the result is salt plus hydrogen. And whenever a gas is given off during a chemical reaction, so what you will observe when this reaction occur, you will observe bubbles. The gas will go, it passes through a delivery tube and then it is collected here. The graph were drawn from the result expected for each experiment 1 and 2. Label the axis. Label the x-axis here. What should be on x-axis? We should have time and always use the unit, like example, it is in second. Give the volume of a gas at which two graphs will level out and compare these volumes. So what is the volume of the gas when these two graphs level out? So for experiment 1, what is the volume? 80. And for experiment 2, what is the volume? 40. And when we compare whenever you're comparing, it means take a ratio. So what, give the volume of a gas from these two graphs. Experiment 1, it was 80. Experiment 2, it was 40. And what is the ratio of experiment 1 to experiment 2? So 80 and 40, when you take a simplest ratio, it's about 2:1. So in experiment 2, the volume is twice the volume of experiment 1 compared to volume of gas in experiment 2 is twice. So ratio is 2:1. Suggest why the graphs level out at different volume. What is the reason why why there is a different volume of a gas given off? In experiment 1, we have greater volume of a gas as compared to experiment 2. What is the reason for that? Why the two graphs level out at different volumes? What is the reason? So different amount of reactant use. That's why it will level out at different volumes. If it were same amount of reactant used, then it will level out at the same volume. The graph has been drawn again. So they draw another graph, draw a curve expected if experiment 1 was repeating the same mass but magnesium powder. So if I use a magnesium powder but same mass, what will be the change? Because if mass is same and powder is there, so powder means large surface area. So large surface area means the reaction will be faster. So it will be steeper. It will be steeper, but the final volume will be same because we use the same amount. Another experiment, a student investigated the rate of reaction between magnesium with sulfuric acid. The solution GNH acid was in excess in both. Two experiments were carried out. The apparatus was set up as shown, and measuring a 50 cm cube solution G was poured into a conical flask, and then we record the volume of a gas. So what you have to do, you have to complete this here, because this is a measuring cylinder and it is inverted. So if it's an inverted measuring cylinder, definitely the 10 will be here, because when a measuring cylinder, this is upside down, inverted measuring cylinder. So this is when measuring cylinder placed normally. So 10 is down, then 20 will be there, then 30 and so on till 100. But because we inverted, so 10 will be up, then 20, 30, 40 and so on till 100. That's why on the figure you can see that it is 0, 5, 10, because it is an inverted measuring cylinder. So what is the volume of the gas in the beginning? You have to just read these measuring cylinders and find the volume of the gas. What is the volume of the gas in experiment 1? What is this value?
0.
0. What is the volume of the gas in experiment 1 after 20 seconds?
13.
13. After 40 seconds?
25.
25. Then after 60 seconds?
38.
After 40, after 80 seconds?
18.
And after 100 seconds?
39.
Then after 120 seconds, means after 2 minutes? After 140 seconds?
79.
And then after 160 seconds, it is
58.
88. So you have to complete these values. And after 180 seconds, it's about 96. So you have to complete these values, and after completing, plot a result for experiment 1 and 2. Draw two smooth line graph. So you will have the numbers for experiment 1 and 2, and you will draw a smooth line graph. Your graphs will be, because experiment 1, as you can see, greater volume is there, experiment 2. So two graphs will be there, but how they will look like, I'm just roughly sketching a graph. I'm not using any value here. So this was experiment 2. It will not level out here because in the volume is not constant. It will be somewhat like this. This is 95 ended at. One of them is level out at 55. So this one is 55. And the other one will level at 95 or 96, the last value. You will have the points when you join these, and whenever you sketch any graph or plot any graph, it should be labeled. So this one was experiment 2 and this one is experiment 1. You should label on the graph. In the next part, they ask which experiment has had a faster rate and suggests a reason. So which experiment is having a faster rate? Experiment 1 is having a faster rate. And what could be the reason why the rate is a faster? Because maybe the the surface area, large surface area is there, or greater amount of magnesium is there, or more concentrated acid is used. You can mention that. The average rate of a reaction can be calculated the volume divided by time. So average rate, so for first 30 seconds for experiment 1. So what you will do, you will have a graph, as you will have a graph for experiment 1. So for first 30 seconds, you will find what is the volume, and volume divided by time, you will get the average rate. Because in the question they mentioned for first 30 seconds only. Calculate the rate for first 30 seconds. So find the volume when the time is 30 seconds and volume divided by time, which is 30, you will get the rate. The unit of the rate is centimeter cube per second. Why? Because the volume is centimeter cube and time is in second. Why eventually no more gas produced? Because the reactant used up. Suggest the effect on the rate using a same mass of magnesium powder instead of magnesium ribbon. So magnesium powder will have a faster, steeper rate because large surface area, more effective collagen, which result in faster for a greater rate of formation of product. Give one advantage and one disadvantage of using a measuring cylinder to measure the volume of solution. What is the advantage of using a measuring cylinder? Measuring cylinder advantage, we can transfer quickly. Like if I want to transfer the solution, I can transfer solution quickly. That's an advantage. But what is the disadvantage of using a measuring cylinder? It is not accurate in measuring the volume. Suggest one improvement to this experiment. What we can do, we can use a pipette or burette to measure volume, because burette and pipettes are accurate in measuring the volume. So we can use either a burette or we can use a pipette. Is this clear?